Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good day to everybody. Okay, for today's lesson, we are going to cover quadratic functions under the subtopic of type of roots of quadratic functions. Okay, let's begin. Okay, the objective for today's lessons are relate type of roots of equations to the discriminant values, solve problems involving type of roots of quadratic equations. Okay, first of all, let's explore. Okay, you are given a table. Okay, this table. Okay, we need to complete this table by using calculator. Okay, let's complete it together. Okay, for the first equation or for the first algebraic expression, we have y equals to x squared plus 5x plus 4, in which we know that the basic or the general form for quadratic expression is y equals to ax squared plus bx plus c. So from here, we can see that, a is equals to 1, b is equals to 5, and our c is equals to 4. So the same goes to the other expression. Okay, so for y equals to x squared minus 6x plus 9, our a is 1, our b is negative 6, and our c is 9. Meanwhile, for y equals to 9x squared minus 6x plus 2, our a is 9, our b is negative 6, and our c is 2. So, after we have the values of a, b, c, we need to find the discriminant. So, this is what we call the discriminant. Discriminant is actually the values for b squared minus 4ac. Okay, so by using your calculator, okay, just find the value for b squared minus 4ac, in which in this case our b squared is 5 squared minus 4 times 1 times 4. So basically we will have 9. Okay, so the same goes to the second one. So our b is negative 6, so negative 6 squared minus 4 times 1 times 9. So we will have 0. Okay, the last one, negative 6 squared minus 4 times 9 times 2, we will have negative 36. Okay, so these are the discriminant that we have from the expressions. So from here, we need to find the roots of the equation. Okay, the roots, in which when we talk about roots, we are talking about the values of x. So you need to solve the quadratic. Okay, so how? Based on the three methods, whether you do factorization, completing the square, or formula. Okay, so since we just need to find the value, so I'm suggesting you to use your calculator lah. Okay, so if we use our calculator, so we will see that for y equals to x squared plus 5x plus 4, we will have two values of x, which are x equals to negative 1 and x equals to negative 4. Okay, two values of x, two different values. Okay, however, for the second quadratic, which is y equals to x squared minus 6x plus 9, by using the calculator, so we will have x equals to 3. Okay, remember that when we talk about x equals to 3, it's not that it is one value, it is two values. Okay, because quadratic need to have two roots. Okay, we will have two values. It's just that in this case, the values are the same, which is x equals to 3. Okay, and for the last one, when we solve by using calculator, okay, so Okay, so, okay, as you can see, okay, look at your calculator. As you can see, we have the value of 0.333, right? But however, look at the top right. There is Ri, right? Ri, I mean like this. Ri. Lebih kurang macam tu. Okay, so this means that this is not real numbers. Okay, not real numbers. So in this case, the values of x that we are looking for is real numbers. However, by using calculator, yes, you have the values 0.33, right? So it's not like I said before, at the top right there is that symbol Ri. Okay, that Ri symbol means that it is not a real numbers, it is not a real values. So we cannot say that, oh, for this quadratic expression we have the values of x. Okay, so let's say okay, the formula is x equals to negative b plus minus discriminant over 2a, right? So for this one, if we substitute, we have negative of negative 6 plus minus square root of negative 36 tadi. Okay, over 2 times 9. Okay, as you can see, so far, what we've learned that square root numbers cannot be negative. Square root numbers cannot be negative because we are talking about real numbers. Okay. However, in mathematics, when we have square root number, which is negative, it is a kind of number, but we state it as complex number. Okay, we said that as complex number. So this is what we call complex number. Okay, so since it is a complex number, it is not a real number. So in this case, we cannot say that x has roots. Okay, however, okay, complex number, okay, this is also considered as 6 plus minus. Okay, we know that the square root 36. Okay, we can write it as like that. Okay, ataupun buat okay, so square root 36, we know that square root 36 is 6. Okay, square root 36 is 6. However, negative 1 is what we call square root negative 1. Square root negative 1 is what we call as imaginary number. Okay, square root negative 1 is equals to I. Okay, square root negative 1 is equals to I. Or we call it as imaginary number. Okay, remember square root negative 1 is a number in which we call it I as imaginary number. However, the number is not real. It is complex number. Okay, so we can say that, oh, this is actually 6 plus minus 6. 6 plus minus 6i over 18. In which, okay, actually we have two values. So 1 plus I over 3, and the other one is 1 minus I over 3. Okay, so the roots actually is this one lah. Okay, in which we can say that, oh, this is not real. Sorry, not real numbers. Okay, I hope you can understand this. So in conclusion, we can say that from these three expression, okay, from these three expressions, only two quadratic expression that has roots. Okay, the first case, we have two different roots. Two different real roots. Okay, two different real roots. Because what? We are talking about real roots. Okay, two different real roots. And for the second one, we have two equal real roots because we have the same number, right? Okay, so I would write here as, okay, so this one, we will have two different real roots. Okay, for the second one, we have two equal real roots. And for the third one, since we said that, oh, the value of x that we have is a complex number, in which complex number is not a real number, so we said that it has no real roots. So these three types of roots, these are the three types of root. Okay, two different real roots, two equal real roots, and the last one is no real roots. Okay, so these are the things that we are going to learn for today. Okay, let's look at the graph. Type of roots of quadratic function. Okay, so as you can see here, for the first expression, okay, for the first expression, we will have this type of graph. Okay, as you can see that, okay, as we know that roots is the value of x. Where is the value of x? The x values that lies on x-axis. So we are talking about the x-intercept actually. Okay, roots is actually the x-intercept. Okay, the x-intercept. So where is the intercept? Here. Let me change color. Okay, where is the intercept? Here. Okay, so what kind of type is it? It is two different real roots because it lies on two different values. So the relation between the type of roots with the discriminant, okay, with the discriminant, so when we have two different real roots, we said that, oh, the discriminant must greater than 0. The discriminant must be positive. Okay, remember, when we talk about two different real roots, we need to relate it with discriminant in which the discriminant is positive. The discriminant must be greater than 0. So how about when the discriminant equals to 0? Let's look at the graph. Okay, so this is the type of graph for the discriminant equals to 0. Okay, what type is it? It's two equal roots. Because of what? Okay, we can see that it lies here. Okay, only at one value of x-intercept. But remember, it doesn't mean that the value of x is 1. Okay, when we talk about quadratic must have two roots. It's just that the roots is the same. The roots have the same value. Okay, so when we talk about the discriminant b squared minus 4ac equals to 0, we are dealing with two equal roots. So the graph must intersect the x-axis at one point. Okay, let me remind you again. When we talk about two different real roots, okay, the discriminant must be greater than 0. And how about the graph? The graph must touch the x-axis at two different points. However, for two equal roots, okay, the discriminant b squared minus 4ac is equals to 0. And how about the graph? The graph must touch the x-axis at one point. Okay, so let's look at the last type of root. Okay, so the last type of root, the discriminant must be less than 0. Okay, let's look at the graph. Okay, let's look at the graph. Okay, so this is the graph for no real roots. Okay, what is the difference? The difference is the graph doesn't touch the the x-axis. Okay, the graph don't touch the x-axis. So if you see the graph, if you see a graph in which the graph doesn't lies or doesn't touch the x-axis, therefore, what type of root is it? The type of root is no real root. Okay, no real roots doesn't touch or doesn't lie on x-axis. How about the discriminant? The discriminant must be less than 0. Okay, the discriminant must be less than 0. So these are the relation between the type of roots with discriminant. Okay, remember we have 3 types of roots. Okay, when we talk about 3 types of root, the first one, 2 different real roots. Okay, 2 different real roots, so we relate it with the discriminant. So the discriminant must be greater than 0. And how about the graph? The graph must touches the x-axis at 2 points. Okay, the second one, 2 equal roots. 2 equal real roots actually. 2 equal real roots. How about the discriminant? Discriminant must be equal to 0. So the hint is equal. Okay, both the name of the type of the roots and the discriminant must have equal. Okay, so how about the graph? The graph must touches the x-axis at 1 point only. Okay, at 1 point only. Okay, meanwhile these 2 points. Okay. Okay, how about the last one? The last type of roots is no real roots. Okay, no real roots, the discriminant must be less than 0. How about the graph? The graph will not touch or lies on the x-axis. So that's it. Okay, I hope you can understand. Okay, let's look at example 1. Determine the type of roots of for each of the following quadratic equations. A, 2x squared minus 3x minus 2 equals to 0. B, 3x squared minus 4x plus 5 equals to 0. And C, 4x squared minus 4x plus 1 equals to 0. So A. So first of all, identify the value of A, B and C. So for A, we have our A is 2. Our B is negative 3. Okay, remember negative, okay? Negative 3. And C is negative 2. So when we talk about the type of roots, okay, type of roots, so you need to relate it with discriminant, B squared minus 4AC. By hook or by crook, we need to relate it with discriminant. So before we said that, okay, we have 3 types, right? We have 3 types. So B squared minus 4AC greater than 0, we said that, 2 different roots. When we have B squared minus 4AC equals to 0, we said that, we have 2 equal roots. However, for B squared minus 4AC less than 0, we said that, no real roots. So in your mind, you need to remember that. Okay? In our mind, we need to remember these things. Okay, so how can we determine the type of roots? Of course, we need to find the value of B squared minus 4AC. So first of all, we need to know what is the value of A, B and C. So after you determine the values of A, B and C, just substitute the values in discriminant, B squared minus 4AC. So in this case, for A, when we substitute the values of A, B and C, we have 25, in which 25 is actually greater than 0. Okay, greater than 0. So that is why we can say that, for A, the type of root is two different real roots. Okay, I hope you can understand, because this is the simplest part. Okay, the simplest part. Okay, for B, okay, we can say that, oh, this is our A, this is our B, and this is our C. Okay, so determine the values of A, B, C, and then substitute in the discriminant. Okay, B squared minus 4AC. So from here, we calculate it, we have negative 44, in which negative 44 is less than 0. Okay, so when the discriminant is less than 0, what type of root is it? It is no real roots. Okay, it is no real roots. Okay, how about the last one? Okay, the last one. Okay, the last one, the discriminant is equal to 0. So, when the discriminant equal to 0, the type of root is two equal roots. Okay, as simple as that. Okay, remember, I remind you, when we talk about type of roots, we need to relate it with discriminant. Okay, in that case, we have three cases. If the discriminant is greater than 0, so it is two different real roots. If the discriminant is equals to 0, so it is two equal roots. However, if the discriminant is less than 0, therefore the type of root is no real roots. Okay, let's look at example 2. Find the values of P if the quadratic equation x squared minus 2px plus 2p plus 3 equals to 0 has two equal roots. Okay, so the hint here is has two equal roots. So this is the type of root. What type of root? Two equal roots. So remember, when we talk about type of roots, we need to relate it with the discriminant, the value of the discriminant. So we know that, oh, when we talk about two equal roots, we said, oh, the discriminant should be equals to 0. So first of all, identify the value of A, B, and C. Okay, so we know that the basic one is ax squared plus bx plus c equals to 0. Therefore, our A is equals to 1. Our B is equals to negative 2p. And our C is equals to 2p plus 3. Okay, so we know the values of A, B, and C. So we also know that the type of roots is two equal roots. Therefore, what are we going to do? We need to substitute all the values of A, B, and C into the discriminant equals to 0. So let's look what will happen. Okay, let us look what will happen. So, when we substitute the value of A, B, and C, we can see that we will have a quadratic equation in which p squared minus 2p minus 3 equals to 0. So, of course, the question asks for the values of p. So, p is equals to y. Okay, p is equals to y. So, if we have quadratic equations and we need to solve it, so of course, by that three methods lah, factorization, completing the square, or formula. So, in this case, if we do the factorization, we know that, oh, p, okay, p squared. So, negative 3 and 1. So, we will have negative 3. So, cross, multiply. If we add both, we have negative 2p. So, that is why our factors is p minus 3 and p plus 1 equals to 0. So, what is our value of p? Our value of p is p equals to 3 and p equals to negative 1. Okay, so we have proven that, oh, this equation has two equal roots. Okay, two equal roots pula. Betul lah. Okay, it's just that the value of p, what is the value of p? In order for the equation to become two equal roots, the values of p are p equals to 3 and p equals to negative 1. Okay, I hope you can follow. Okay, let's look at example 3. Show that the equation kx squared plus 1 minus 2kx plus k plus 3 is equals to 0 has roots which are different. See? Roots which are different. So what does it mean? It means that we have two different roots. Okay? If k less than 1 over 16. Okay, first, the word show that. Show that means proof. So when we talk about proof, from the beginning until the end, this is the result. The end of our solution must be k less than 1 over 16. Okay, next we said that the roots which are different. When we talk about roots, when we talk about roots which are different, we are saying that it has two different real roots. So, how about the discriminant? The discriminant must be greater than 0. Okay, the discriminant must be greater than 0. And then, we need to find the value of A. So, what is our A? So, actually, our A is K. Our B is 1 minus 2K. And our C is K plus 3. So, what should we do? Substitute the values of A, B, and C into discriminant greater than 0. And then, look. And then, after substituting, we need to simplify or whatsoever until the end of our solution became k less than 1 over 16. So that is proof. That is how we solve show that or proof. Okay, so let's look at the solution. Okay, see? First determine the value of A, B, and C, and then we substitute the values in B squared minus 4AC greater than 0 because of what? Because the roots is two different real roots. So from here, okay, we expand, and then we simplify. So we can see here, negative 16k is greater than negative 1. See? From here, we still have greater than. However, the answer became less than. Why? Because the coefficient of k is negative. That is why the answer changed from greater than to less than. Okay. So I hope you can understand. Okay. This is what we said proof. Okay. The answer, see? The answer at the end of the answer, at the end of the solution, it became k less than 1 over 16. Okay. Let's move at example 4. Okay. Given that the equation x squared plus 4mx plus 3n equals to 0 has two equal roots. Two equal roots. So, two equal roots means the discriminant is equals to 0. Okay. So, what is the value of A? A equals to 1. B equals to 4m. And C is equals to 3n. Find m in terms of n. So, the same thing, substitute the values of A, B, and C into the discriminant equals to 0. Okay, when we talk about m in terms of n, m is the subject. Okay, so let's look at the solution. Okay, see? We substitute the values of A, B, C into discriminant equals to 0. So from here, we say that, 16m squared equals to 12n. And then what is m squared? M squared is equals to 3 over 4n. Okay, so m is equals to square root of 3 over 4n lah. Okay, when we talk about square root, we have positive, negative. Okay, so how come this the final answer becoming m equals to positive, negative square root of 3n over 2? Because square root of 3 over 4n is also means square root of 3n over square root of 4. So we know that square root of 4 is 2. So that is why the answer is m equals to positive, negative, set 3n over 2. Okay, simple, right? Okay, let's move on. Example 5. Show that. Okay, show that. So again, we need to prove. Show that the quadratic equation x squared plus 6x plus p equals to 0 has no roots if p greater than 9. No roots. So no roots, so we relate it with discriminant less than 0. So what is our value of A? A is equals to 1, B is equals to 6, and C is equals to P. So what should we do? Substitute all the values of A, B, and C into discriminant less than 0. Okay, so let's look at the solution. Okay, so this is what we get when we substitute the values of A, B, and C. So we can see here, oh sorry, I'm missing 4 here, okay. Okay, so we can see that negative 4p less than negative 36. Okay, again, the coefficient for p is negative. So we can see that, oh, from less than p, when we talk about p, so it will change the sign from less than into greater than. So we can say that, oh, p is greater than 9. So at last we have proven, okay, we have proven that the equation that has no roots, okay, the end of the solution is p greater than 9. Okay, simple, okay. Okay, next example. Example 6. The equation x multiplied with x minus 2 minus k to x minus 1 plus k squared equals to 0 is satisfied by two distinct values of x. Find the range of values of k. So what does two distinct values of x mean? It means that it is two different roots. So when we talk about two different roots, we are talking about b squared minus 4ac greater than 0. Okay. So, what are we going to find? We need to find first what is A, what is B, what is C. The problem is the equation given doesn't give us the values of A, B, and C easily. Okay, so what should we do? We need to expand and simplify the equation until it became in the form of ax squared plus bx plus c equals to 0. Okay, so after we determine the value of a, b, and c, again we substitute the values into discriminant greater than 0. So let's look what will happen next. Okay, so the first part, okay, what I did here is I expand from the original equation so that at last we have x squared plus negative 2 minus 2k of x plus k squared equals to 0. So from here we have transformed it into ax squared plus bx plus c equals to 0. So the value of a is 1, b is negative 2 minus 2k, and our c is k squared plus k. So substitute all the values into discriminant greater than 0. So at the end, we find that, oh, k is greater than negative 1. So this is the range of values of k. So we have solved this problem. Okay, simple, right? As you can see, the process is the same. Okay, the process is the same. First, look at the keyword, whether two distinct root or no roots or equal roots. Okay, which means from the keyword we know what type of roots and we can relate it with discriminant. Okay, in which case discriminant is whether it's positive, greater than 0, or equals to 0, or less than 0. Okay, so from there we need to find A, B and C. So how? We need to perform it or transform it into ax squared plus bx plus c equals to 0. Only then, after we have the values of A, B and C, only then we can substitute with the discriminant. Okay, all the examples have the same procedure. Okay, I hope you can understand. Okay, next, evaluation. So I would like you to do these 3 questions. Okay, these 3 questions and discuss the answer with your teacher. And last but not least, homework. Okay, so this is your homework for today. Okay, self-practice 2.5, question 1 until question 5. And intensive practice 2.2, question 1 until question 8. Okay, so before I end up my session, okay, class, success is the sum of small efforts repeated day in and day out. So never give up. Never give up. Never give up. Always give your best. Always do what you need to do. Okay? You need to learn and learn and learn. Okay? Remember, it's the sum of small effort. Success is the sum of small efforts repeated day in and day out. So never give up. So good luck and all the best for me. Thank you for your time. Thank you for your commitment. Let's see you guys in the next class. Okay. Assalamualaikum warahmatullahi wabarakatuh. And peace be upon you. Thank you.